Hello students, welcome back to our AriserTalent. I am your maths teacher Arpita Sharma. Students, we are discussing this chapter circles and we have gone through some theories and some important theorems of that. Okay, so studied that, revised all these things. Okay, students, now we are going to consider a new theorem. Okay, and this theorem is about the chord and the bisecting the chord and center, and we will look around it. Okay, so what is it? See, the perpendicular from the center of a circle to a chord bisects the chord. What does that mean? If I am having this circle, because whatever it's having, it's compulsorily including a circle, isn't it? Okay, so I am drawing a circle here. Okay, and about my circle, you know, whether it looks like a complete circle or not, you have to assume my circle to be circle only. Okay, let's consider this, and just for your convenience, I am just making it correct. Okay, so I am just correcting it for you, right? Okay. Now this is a good circle of ours. Now it's saying that what? The perpendicular from the center of the circle. Now this is the center of the circle. Let it be this. So this is the circle, center circle O, and right, it is exactly not looking like a circle, right? That should be like this. Is it now? No. Okay, so forgive me for this. Now, center of the circle. So this is the center of a circle. The perpendicular from the center of a circle. Perpendicular from the circle to what? To the chord. So this is the chord. I have to draw a chord, and I am taking 2 points in order to do that. That will be AB. Now if this is the center of the circle, so from this center of the circle, I have to draw a perpendicular, right? So this is perpendicular, students. Okay. Right. Now, okay, I will draw lines here also. Okay. Now I am having this point O, and this perpendicular meet it at point P. That's saying that to a chord bisects the chord. That means what we have to prove is that this AP is equals to PB, because if AP equals to PB, then only this perpendicular will bisect this chord. So basically this is saying that if you are having a circle and you are having a chord in that, and you draw a perpendicular from the circle from the center to the chord, then this chord will be bisected. This is you have to prove. What is given to you guys? That this is perpendicular. Okay, so we will make good use of it in order to prove that. Okay, so here is the given part. What is given, students? What is given? Given is OP is perpendicular to AB. OP is perpendicular to AB. Okay, this is given, and AB is chord. Right? Now, to prove, what you have to prove? That this line AB is bisected by this line OP. That means AP is equals to PB. Okay. So to prove AP is equals to PB. Okay. And what we have constructed for that? Okay, because this is a perpendicular, right? Okay. Now we have meet O to N, O to B, right? We have to prove. Okay, proof here. Before proof, we are having some construction right there. Construction. So construction is meet O to A and O2B. Okay, now proof, not puff but proof. Okay, so what is the proof? We are taking two triangles. This is we are doing from the very beginning. We are taking these two triangles in this case. In triangle OAP and OBP. Okay, in these two triangles, what are we having? Angle P equals to angle P. Which angle P? OPB is equals to OPB. Why? Because equals to 90 degree, these both are equals to 90 degree. Why? Because this OP is perpendicular to AB given. Okay, so this is the first thing. Now OP equals to OP. Why? Because it's the common side. OP is the common side between these two triangles. Okay, so this is common side. This is angle which is both equals to 90 degrees, so that will be equal. Okay, after that we will be finding OA equals to OB by the same concept we have used before in previous theorem. What? That these are radius of a circle. Radius of circle. So what you got? Side angle side property. So by side angle side congruency, what? Triangle you can say triangle POA is congruent to triangle POB. Okay, and that means AP, that AP will be equals to BP, okay, or PB. That's what you have to prove. So hence proved. Any doubts about that? No? Copy it. Copied? Okay, so noted. Okay. Okay, so this next theorem is just opposite of that, you can say the converse. Okay, so converse of this is the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. Okay, okay. Now how will we tell that? Is it a good circle or not? My circle has been improved. What do you say? Okay, so this is the circle, right? I will sharpen it. So this is our circle. Now it's saying that the line drawn through the center of a circle to bisect a chord. Now we are having a chord here. Okay, so this is my chord. I was having 2 points A and B, and what I did, I just draw a line through the circle, through the center of the circle. I draw the line and that met this chord AB at some point P, and this was the point O. Now it's saying that it's this line here is dividing this line AB in two halves, like AP equals to PB. Now it's telling us that prove that this OPB is equals to this OPA is equals to 90 degree. These two angles are 90 degree. Okay, so this we have to prove, and we have provided with the information that this OP is bisecting this. Now whether it's a perpendicular bisector or not, we have to prove it. Okay, so we will start doing this. What we write? Given. Okay. After given, we will do the to prove, then construction, and then proof. Okay, very good. Now we'll be having these given thing. Given is what? Circle C1, the center O, okay. AP is equals to PB, this is given, okay. Now what we have done, what we have to prove, we have to prove that this angle OPA is equals to angle OPB equals to what? 90 degree. It's perpendicular. If it's perpendicular to, if this line is perpendicular to AB, then that will be these two angles will be 90 degree perpendicular. Okay. Construction, we have done this. We have made O2A and O2B. So construction, meet O2A and O2B. Right. Okay. Now proof. What we are having here is AP equals to PB. AP equals to PB. First thing. Why is it so? Because it's given, it's so obvious, it's given. We have written it here also, AP equals to PB. Now the second thing, this is the common side. OP is common side. So OP equals to OP. This is what? Common side. What, students? Common side it is. Okay. Now come here. This OA equals to OB. This OA equals to OB. Okay. So OA equals to OB. Why? Radius of circle. Okay. So basically this AP is equals to this OP is equals to OP, then this OA equals to this OB, and this is given AP equals to AP. That means student, this triangle OA and P, OA and P is similar to this triangle OPB, OBP. And when I say similar to, what does that mean? Okay, look, whenever, okay, so by this side, by side, congruency. Okay, what will we have? We have this triangle APO is congruent to this triangle BPO. Okay, and if you go to this congruency, you are having this angle P is equals to that angle A. This angle P is equals to this angle P. That means this angle APO will be equals to this angle BPO. Right? Now, student listen, this APO, this is the angle, okay, and BPO, this is the angle, okay. Right now, I have not proven that this is such kind of 90-degree angle. So, I am talking about this one angle and this one angle. Right. Now, these two angles are equal. Okay. But student, listen to me very carefully. This is a line, and whenever you draw a line and you are having any point here, what's this angle? This angle is equals to 180 degree. So, basically this angle and this angle is equals to 180 degree. Okay. But AB is a line segment. So, angle this APO plus angle BPO equals to BPO equals to 180 degree, right? Okay, it is 180 degree, but these two angles are equal, right? So, okay, what we will see, but angle APO equals to angle BPO. This implies that this will be what? If it's equation 1 will be equals to angle APO, and I will replace this angle BPO by APO. I can do that because these two angles are equal. APO equals to 180 degree. That means two angle APO equals to 180 degree, and for one angle like angle APO will be equals to what? 180 by 2. This implies angle APO equals to angle BPO equals to 180 by 2. That means angle APO equals to angle BPO equals to 90 degree. Right? And this is what we have to prove. Hence proved. What you realize here that we have taken these two. So, these are basically 90 degrees. Okay. What we have done, I am just revising that. We had a center here, we have given with this chord, we have given this OP is bisecting this line into two equal halves, that means AP is equals to PB. This information we have given. So, we just meet O2A and O2B. After that, we took this particular triangle here and this triangle here. After taking these two triangles, what we did, we have this OP side common, OB equals to OA and this AP equals to PB given. Then we proved by as congruency that these two triangles are equal. These two triangles are equal and this angle is equals to this angle. Now, if these two angles are equal, but this is what? A line segment, and we are having any point on a line segment, that this angle will be 180 degree. So, basically this angle equals to this angle and the complete angle is 180 degree. That means each angle is half of 180 degree. That means this is 90 degree and this is 90 degree. Basically this is 90 and this is 90. So, this is OP is perpendicular to AB. Okay. So, this is the way we have proved that. Now, note it. Noted? Okay. You know, all the theorems concerned with this circle chapter have all the things to do with the congruency of the triangle. You know, you all know the congruency of the triangle or not? Students, are you aware of the congruency of triangle or not? You can have the videos, your lecture videos of smaller classes, okay, and in that you can have all these congruency of triangles. Explained very well. Okay, so basic this you know na, that if you are having two triangles and these three sides are equals to these three sides, that means this side equals to this side is equals to this side, this side is equals to this side. That means each and every side of this triangle have to be equal to each and every side of this triangle. If you have to, if you are able to prove that, that means this and this triangle are what? Congruent to each other. This theory works. And if you have proved that two sides and one angle are similar, then also the triangles are congruent. If you take two angles and one side, then also if you have taken three sides that I have earlier mentioned, and we have used this property also here, then these two triangles are congruent. But in the case of three angles, like angle and angle, no, congruency will not work like this way. Okay, that can be in this way. Okay. And what does that mean of congruency exactly? This is something like these two chalk holders. Chalk holders I am only talking about, not these chalks. Okay, so in the shape and the size also, these are similar, exactly similar to each other. If I'll just have that and you will be just seeing them, that will overlap, they are identical. What I mean to say, they are identical, not even similar, they are identical. Every dimension, each dimension of this is equals to each dimension of this. So these are two what? Basically identical pieces. And whenever you go and purchase something, like you're having that in 1 kg, half kg packages. So that half kg is just similar to the 1 kg box. Okay, just the difference is the dimensions are greater in the 1 kg and the shorter in the half kg. These two things are not. These two things are not congruent to each other. But when you are having some package of 1 kg, okay, and you are having one same brand and same stuff, you are having the exact another piece of that 1 kg. Okay, and then this 1 kg and this 1 kg are actually similar, not similar, identical these are. So this half kg and 1 kg are similar, but this 1 kg and 1 kg are what? Are congruent to each other, they are identical to each other. So in that case we think like this. Okay, so our next point, our next topic, what is our next topic? So circle through 3 points. So it's mean that we are having 3 points here. Okay, now I have to draw circle. I have to draw circle through these 3 points. Okay. I have to take these 3 points again. Okay. So now let's suppose I am drawing this circle from these 3 points. Now is it, guys, possible for us to draw another circle having these 3 points in it? Is it possible for us, guys, to draw a second circle having these 3 exact points in it? Is it possible or not? What do you think? What it is? It's possible or not? So think about it, because we are going to discuss the same topic in our next lecture. Okay, for today it's fine enough. We are meeting in our next lecture with this 3-point concept, and try to make circles, okay, with the 3 point. And when you have drawn a particular circle through these 3 points, try to draw another circle from these 3 points also. Okay, so do it. Bye bye for now.